Now for the ANOVA, you're at the point of evaluating your result. This is the fourth overall step in hypothesis testing for scientific inquiry using an ANOVA. So, in the previous step, we determined that your F statistic, or what's called your obtained F, was 6.50. And you remember that the F critical value that we identified before you started doing your ANOVA calculations was 3.36. So now we compare the value of the obtained F to the critical F, and obviously the obtained F exceeds the critical F. But remember, the amount of difference that you see between these two values does not tell you anything about the size of the effect in your particular set of data. Before we get to that, let's just review again this same statement that you can make using symbols. The summary of your conclusion when you do this comparison of the obtained F to the critical F, you write reject H0, which is the null hypothesis, comma, F, parenthesis, 2 and 27. So notice that when you report your F statistics in the text of a results section, you report your degrees of freedom between and your degrees of freedom within. And again, that's to give the reader the opportunity to evaluate your finding relative to the critical F that reader can look up on the basis of this information, right? So F, parenthesis, 2, comma, 27, and parenthesis equals 6.50, comma, P is less than 0.05, meaning that this value of F indicates a statistically significant effect that is that is below a 0.05 alpha level. All right, so all of that is fine, and we know we have a statistically significant result, but we can't stop there. That really doesn't tell us all that much. We want to find out what the effect size is here, right? So you have to calculate effect size. Now for ANOVA, the effect size measure that we use is referred to as eta squared. And this is the symbol, and you draw it like this. It's kind of a big N with a loop at the bottom. So I've put eta squared here. And eta squared is calculated in a way that's now very simple given all your previous calculations. You simply divide the sum of squares between by the sum of squares total. So here you're just finding out how much of the sum of squares total is accounted for by the sum of squares between. So again, this symbol, this big loopy N with a square by it, is referred to as eta squared. So let's do that calculation. It's very simple. Sum of squares between, you have written down on your piece of paper, no doubt, is 43.8 divided by 134.70, which was our sum of squares total. And for that we get 0.325, which will round to 0.33. And as you remember, the effect size for this finding would be considered small, right? All right. Now, I just want to point out something. The difference between this obtained F and this critical F might have seemed like a lot to you, especially given some of our previous findings, our previous examples. But remember, the amount of difference between your obtained F and your critical F will not give you any indication of what kind of effect size the effect size measure will produce. So you always have to determine what your effect size measure is after you have calculated your F statistic or T statistic.